How do we balance these? Of course we do, as I outlined in an earlier video linked to in the description below and floating over my head, by adding coefficients, which are numbers to the left of each of these chemical compounds. Remember, when balancing reactions like this, you do not and cannot change subscripts, the tiny little numbers here, or charges that are sometimes written floating over the compounds or elements in the formulas. I don't have any in this example. You cannot change those. You can only change coefficients, which are the things that appear to the left of each term. Does that make sense okay? The way that I like to do it is I read it left to right, and I first identify or make a list of all of the elements that appear on the left side of the equation, that is on the left side of this reaction arrow. As I read left to right, I've got a carbon, and I've got oxygen and another oxygen, so I just write a C and an O, and I kind of like to write a line there to indicate how many of those I have. And then I'll do the same thing for the products on the right side of the reaction. Now we'll take a look. How many carbons do I have total on the left? Everything to the left of the arrow? Well, I only have one. How about on the right? I only have one. So as far as the carbons go, these are balanced because I've got the same number of carbons on both sides. Now to the oxygens. I've got one oxygen here, and I have two oxygens here implied by that two subscript. So 2 plus 1 is 3 total oxygens. On the right side, I have 2, so that is not balanced. So what can I do? Again, you might be tempted to start changing subscripts, but if you do that, you'll get it wrong. You can't change subscripts. You can only add coefficients. So at this point, it might seem a little bit tricky what in the world we could do. Well, let me teach you something kind of special. As it turns out, you actually can use fractions as coefficients, at least on your initial go through in order to make everything balance, okay? Now, we'll fix that at the end to make everything not fractions, because typically on exams and other things, we want to make them not fractions most of the time, but you don't always have to. Anyway, just wanted to get that out there. So again, on the left side of the equation, I have 3 total oxygens, and on the right, I have a 2. Is there some number, be it a fraction or otherwise, that I could put right here that when multiplied by 2 would make these oxygens match? Hopefully you can see that if I took 3 halves right there, 3 halves multiplied by 2, the 2's cancel each other out, so I would be left with 3 oxygens on the right side of the equation. You see that okay? Now, one of the issues that you'll see happening there is that it changes the carbon count. So the carbon count is now wrong, so I need to multiply the right side by 3 halves. What you can see is going to end up happening is I'm going to end up in this never-ending circular spiral of changing the carbons and changing the oxygens and back and forth in a way that will get very frustrating very quickly. So one thing that we want to see if we can do is focus on the oxygen here that is not tethered to a carbon along the way. Nevertheless, for the sake of fun, I'll go ahead and write down my change. You'll notice that I've got 3 halves multiplied by oxygen here, plus another 2 oxygens is 4 halves, plus 3 halves is 7 halves, and you'll notice that that kind of just messed up my oxygens, didn't it? So what in the world can I do? Well, what if instead of placing a coefficient right here, what if I went backwards and instead placed my 1s here for my carbons? I still have now 3 total oxygens on the left. What if instead, and I guess I have 2 oxygens on the right, what if I instead focused again on this oxygen that's not tethered to a carbon and did something to it? Is there any way I can decrease this number from 3 down to 2 total for the left side of the equation in order to match the 2 oxygens on the right? I bet I can if I put a 1/2 coefficient to the left of that oxygen. You see, 1/2 multiplied by 2 is 1. Does that make sense? So if I put a 1/2 there, I now have 1 oxygen total here, plus the 1 oxygen there adds up to be 2. You see how that works? And that's beautiful when you're kind of looking at this and navigating back and forth. Again, you can see that if I mess with this, it ruins the carbon, and then I have to go over here and mess with that carbon, and I go back and forth and back and forth. So focusing on the one substance that is not tethered to that carbon makes things a lot easier. Hopefully you're okay with that. So now everything matches. You can see that I have a fraction here, and I might want to get rid of that. Sometimes it's completely acceptable to leave that, but on multiple choice exams, oftentimes they want you to get whole number coefficients. So the easiest way to handle that is to multiply everything all the way through by the denominator of the fraction, which is 2. So if I multiply every single term by 2, I get 2 multiplied by the implied 1 here. That gives me a 2 right there. 2 times 1/2 gives me 1, so I'll just leave that alone, implied 1. 2 times the implied 1 here is 2. Now let's see if our equation is totally balanced, okay? So erase everything there. On the left side, I've got 2 multiplied by the carbon. That's 2 carbons on the left. On the right, I have the same thing. On the left, I have 2 multiplied by this oxygen is 2 oxygens, plus another 2. 2 plus 2 is 4 total oxygens on the left. And on the right, 2 times this 2 is also 4. Is it balanced? Absolutely yes. Now let's do the same thing here. I'm going to make my list, carbon, hydrogen, and chlorine on both sides. and start doing my count. Don't, by the way, get the chlorine confused with the carbon. I know there's a letter C in both of them, but they're completely different elements, okay? So on the left side, I've got 1 carbon here, and that's all I have on the entire left side of this arrow, okay? On the right side, I have a carbon here, and that is all. So I'll write down 1 right there. On the left side, I have 4 total hydrogens right there. And on the right side, I've got 1 total hydrogen. So that doesn't match. Is there any way I could fix that? Well, yeah, I bet I could multiply this by 4. 4 multiplies through, and now my hydrogens match. So I'm good on carbons and hydrogens. Now, what about the chlorine? Over here on the left, I've got 2 chlorines, and on the right, I've got 4 chlorines here, plus another 4 chlorines over there. See, because this 4 multiplies through, so I have 4 plus 4 is 8. So I have 8 total chlorines on the right. Now, how can I fix that? Because I obviously don't have 8 total chlorines on the left. Well, I bet if I added a 4 coefficient right there, yeah, 4 multiplied by that 2 gives me 8. So those are the coefficients that I'd have to balance that beautiful chemical equation.